Graph each of the following on a number line. X equals -7. Well, so I just go left 7. 1, 2, 3, 4, 5, 6, 7. So that's -7. So that's my position. I'd fill it in with a solid dot. By the way, the marks I don't have to make along the way, as long as I'm clear about my label. So this is where X is. So X is equal to -7. So now I'm saying if I took my position and added 4 to it, I would be bigger than -2. So the way you solve these is first you figure out, what would happen if it were equal. And so a number I can add 4 to get to -2. So suppose -2 is there. I have to add 4 to it. It has to grow by 4 to get to -2, which means -6 is where I am. But I'm saying that it has to be bigger than -2, which means it can't be equal to 2. It only has to be bigger. So solving for this, I'm saying X has to be bigger than -6. So I put an open circle indicating that it does not include -6, but it gets all the way up to -6 without actually touching it, because -5.9999999 works. If I plug in -5.99, for example, and I add 4 to it, I get -1.99, which is bigger than -2, so that works. So I have to pick all the numbers that are bigger than -6. So I'll indicate it like this, and I'll put an arrow on the end indicating it goes on forever in that direction. Any number I choose, if I pick 100, 100 plus 4 is bigger than -2. Likewise, 3 times my position is less than -15. So what can I multiply by 3 to get -15? Well, X is -5. And so we're saying X has to be less than -5 for this to work. Because if I plug in -6, that gives me -18, which is less than -15. But if I plug in -5, -15 is not less than -15. It's equal to it. So I go to my number line at -5, and I'm saying it has to be less than it, meaning not equal to it. So again, I have open circles saying it's not touching -5, but it's everything below it. So just as a refresher, right? This is less than. This is greater than. So we're going to continue to use these. In the next one, X is bigger than -2 and less than 14. So let's talk about and. And means both have to be true. So where's X? So let's graph these individually. So X is bigger than -2 and less than 14. So bigger than -2 looks like this. Less than 14 looks like that. And where they are both true is where they cross. But it does not include 14, so I have an open circle there, and it does not include -2, so I have an open circle there. So the solution would be what's in purple. Now, for those that maybe don't have the colors I have, one way to draw this would be to have your graph for -2 go up and over like that. The one for 14 go up and over like that, and then you could now shade the in-between to show me where the intersection is. You can't just do the crossing ones because I don't know where the solution is. You need to then color it in on the actual line as to where the solution is. So let's try the next one. X is less than -1. -1, not including it, so going down, open circle. If it included the number, it would be closed circle, and you would see that indicated by an equal sign under the bar. So it would be greater than equal to, less than or equal to. or x is bigger than 3. Now these don't cross at all. So you might say, well, there's no place where they intersect. But this problem has or, and or means where one or the other or both are true, meaning anywhere that anything is true. So this is the solution. The solution is when it's less than -1 or it's bigger than 3. Looking at the next one, x is greater than -2. There's my -2, not including it. Greater than. Or x is less than 0. Open circle at 0. So you notice here that they both cross into each other's circles, and you might ask, well, what do I do with that? Well, because it's or, it's when one is true or the other is true. So at 0, let's just look at one of these cases. So at 0, when x is 0, 0 is less than 0, that is not true. But 0 is greater than -2, that is true, so this is part of our solution. So even though there's an open circle and it crosses through, it still counts in an or. In an and, we'd get a different scenario altogether. So let's just recreate this again. So because it's crossing in both directions, there's not a number I can pick on this number line that wouldn't be true for one or the other. So the way we would indicate this is all real solutions, which you could write with a fancy little r like that, or you can say all real numbers, 1L, sorry, real numbers. So that's how you would indicate that. And there's also a way of saying, well, there's also the possibility for no real solution, which you could represent like that, or an empty set. And we'll get into those details more later. So now we're going to start getting into absolute values. Right? The distance I am away from 0 is 9, which means I'm either at +9 or at -9. So there's two possible answers for this. You need to indicate both of them. The distance away from 0 that I am is less than or equal to 6. So let's look at our equal to scenario. So it's equal to 6, meaning my distance away from 0 is 6, which means I can be at 6 or -6. But I'm also saying that the distance away from 0 is less than 6, less than or equal to 6. So which means 5 is fine, right? That distance away from 0 is less than or equal to 6. -5, -4 is fine. +2 is fine. Everything in between here meets the criteria of less than or equal to 6. If I picked a number out here, like 10, is 10, the distance that 10 is away from 0, less than or equal to 6? No, it's greater than 6, because it's 10 away from 0. The distance I am away from 0 is more than 2. So if I'm 2 away from 0, not equaling 2, I'm either at 2 or I'm at -2. So the distance I am away from 0 is more than 2, which means this distance away from 0 right here is 2, and this distance is 2, and I'm saying my distance is more than 2. So it must be all these numbers out here that are further away from 0 than 2, and all these numbers out here whose distance is further away from 0, further than 2 from 0. Finally, the distance, if you took my position and took 2 away from it, I would be 4 away from 0. So if I'm 4 away from 0, I'm either here or here. So I can't say, well, that's my position yet. But what I'm saying is my position -2 is located there. So what position would I have to take away 2 to get there? Well, in this case, -2 minus 2 is there, so that's one of my positions. Or +6 minus 2. So my solutions are -2 or +6. So a few ideas here came up. One is around how do you find your position, dealing with greater than, less than, greater than equal to, less than equal to. Remember, greater than or less than have open circles on the key points, and less than equal to, greater than equal to, fill in the circle, indicating that that point is part of the solution. We had to deal with some ands and ors. Ands means where they're both true, or means where one is true, or the other true, or both are true. So or is much more inclusive, and is only where they cross, where they intersect, where they're both true. And then we had to plot some absolute values, thinking about the distance I am away from 0, and how do we plot that both with equals and inequalities.